Hello everyone. Today we are going to do IGCSE paper 6 alternate to practical held on 18th of Feb in Indian subcontinent, and it is a 062062 variant, a 1 hour paper, and it is paper 6 alternate to practical. The question 1 of this paper says ink contains different color substances called as dyes. It is a chromatography taking place here. As you can see the diagram, ink contains different color dyes, and a student used chromatography to investigate the color dyes contained in the 6 different inks. There are 6 different types of inks in this diagram we can see, and he drew a baseline on a sheet of chromatographic paper and then placed a spot of each ink on the chromatographic paper and set up the operators as shown here. Now he had made 2 errors. What are the 2 errors we have to identify? Identify the 2 errors the student made. As I can see this chromatogram, and you can see it, this is the water which is my solvent, and these are the colored inks which are placed below baseline. The first point is all these dyes or the inks which we are finding out, the inks which we are using to find out the dyes should be placed on the baseline. So this is the first error we can find out. The ink are placed below the baseline. Ink are placed below baseline. Below baseline, they should be on the baseline. This is the first error. And the second error we can see, if you can observe, this chromatographic paper is not touching the water. It's not touching the solvent. It should touch the solvent so that the solvent can rise and the ink can dissolve in it when the solvent rises up. So it's not touching, therefore there will be no rising of the solvent, no chromatography will take place. The second error is the solvent or the water. Solvent, that is water, is not, is we can say above, is not touching the chromatographic paper. The paper is above, or the paper is above solvent or water. These can be the answers which we will get in the answer key when it comes. Okay, the ink are placed below baseline, they should be on the baseline. And number 2, the ink drops or the sample drops should be below, they should be on the baseline, they are visible below the baseline. State the name of the equipment used to draw baseline. So we generally draw baseline by the help of a pencil, because pencil contains graphite and it do not have any other color or any other dyes in it, therefore it will not interfere with your chromatographic paper or solvents which are using, or with the samples which we are using in the chromatograph. It will not interfere. So pencil and a scale or a ruler we can use for to draw. So this should be the answer for the equipments used to draw baseline on a chromatographic paper. C part is the student corrects the error and then carries out the chromatography. The chromatogram shown in figure is this. We can say yellow, orange. There is one dye in yellow, 2 in orange, 2 in green, 1 in blue, 2 in purple, and 3 in black. Now it's saying identify an ink which would contain only in one color dye. Identify ink which could contain only one color dye. So we have to find out an ink which has only one color dye. So one color dye is in yellow or it's in blue. So we can say the answer for it will be either yellow or blue. You can write yellow ink. Why? Because it has one spot, or blue ink. Yellow or blue ink will be the answer for this question, because both of them have one spot or one dye in it. Deduce which ink would be mixed with blue ink to make the black. Now I want to make the black ink and I have to mix in blue ink. Blue ink has this and black is also this. To make the black, we have to mix these 2 components also, and these 2 components are present in the orange. So I can mix the orange ink with blue ink so that I can get a black ink. Answer will be orange ink. Okay, because when these 2 and this dye will mix, they will convert into a black ink. Black ink contains these 3 type of dyes. Now deduce the color of one dye that is contained in all 3, orange, green, and black. Okay, all 3 inks we have to find out, that is the dye should be present in all 3 types of inks: orange, green, and black. Orange, green, and black. Which dye is present in, which is common in orange? Okay, orange is this. Green do not have this. All of them, they have this dye. Orange, green and black, they have this common dye. So what I can say, deduce the color of one dye that is contained in all the three orange, green and black ink. Now orange, green and black ink contains this dye. Now which dye has this? Only this dye is present in only ink is yellow. So if I can say orange, green and black has a dye which is found in the yellow ink only. The answer is yellow ink. I hope you got it. The second question is, a student investigates the temperature change when aqueous copper sulfate or copper to sulfate, that is CuSO4, reacts separately with two different metals, zinc and iron. It is reacting with zinc and iron copper sulfate. In the first, there are students that does two experiment. Experiment number 1, he took 50 centimeter cube measuring cylinder and pour 30 centimeter cube of aqueous copper sulfate into a 100 centimeter cube beaker. Use a thermometer to measure the temperature of the contents of the beaker. This is the temperature at time t equals to 0. Now add 3 grams of zinc powder to the beaker. At the same time, we'll start the stopwatch. Using a thermometer, continuously stir the mixture of the beaker and then measure the temperature of the mixture every 30 seconds for 210 seconds. Okay. Empty and rinse the beaker with distilled water. Now experiment 2, he's repeating the experiment 1. Instead of zinc, he's taking iron. Now 3 grams of iron and 3 grams of zinc powder. Instead of zinc powder, he's taking 3 grams of iron. Now the data he collected is data of temperature. Complete the table 2.1 by using thermometer diagrams and calculating the temperature change at t equal to 0. Okay. Now in experiment 1, as we can observe, the temperature in this case is 24, which is my noted here, and 0 is the temperature change from 0 degree, because we had started the experiment at 0 time from 24. Now at time 30 seconds, the temperature rise is from 30, 31, 32, 33, and it is between 33 and 34. It means it is 33.5, we can say. Next is 35, 36, 37, 38. Now it is on 38.0, 38.0. Now next is 40, 41, and it is around, but it is below 42. So we can say it is around 41.5. Okay. Next is 40, 41, 42, 43. Next is 43.0. Next 40, 41, 42, 43, 44. Exact on 44, 44.0. Next 41, 42, 43. Next is 43.0. And the last one is 41, 42. It is 42.0. So these are the temperature readings which we had calculated from this. Now I want the difference of temperatures, that is from 0 degree. What is the difference? 33.5 minus 24. What I will get is 9.5. Next is 38 minus 24, that is equals to 14. Next is 41.5 minus 24, that is 41.5 minus 24 is 17.5. Next 43 minus 24, 43 minus 24 is 19.0. 14.0, 9.5, 17.5, 19.0. Now 44 minus 24, 44 minus 24 is 20.0. Okay. Now 43 minus 24, 43 minus 24 is 19.0. And then 42 minus 24, and that comes out to be 18.0. Okay. So this is the reading of this experiment number 1. Now come to experiment number 2. In experiment number 2, initial reading is 22 at time equals to 0. Now the next reading is 20, 21, 22, 23, 24. Next reading is 24.0. After that 20, 25, this is 25, and it is between 26 and 25. So we can say it is 25.5. 25.5 roughly. Then 25, 26, 27. Next is 27.0. Next 25, 26, 27, 28. It is on 28, it is 28.0. Next 25, 26, 27, 28, and it is between 28 and 29. It means it is 28.5. Next 25, 26, 27, 28, 29. It is 29.0. And the next is again 25, 26, 27, 28, and again is 29.0. So these two are 29.0, 28.5, 28, 27, 25.5, and 24. Now the difference of the readings. Now the difference of the reading is 22 minus 24 minus 22. 24 minus 22, that equals to 2.0. Next 25.5 minus 22 equals to 3.5. Next 27 minus 22 equals to 5.0. Next 28 minus 22 equals to 6.0. Next 28.5 minus 22 is again 6.5. Next 29 minus 22 equals to 7.0. And the last is again 29 minus 22, that is again 7.0. Okay, so these are the data table completion. We have to take the temperature change from 0, that is at 0 seconds. Therefore the difference of the temperature at 0 and the temperature at the given time, that is 30, 60, 90, will calculate, and this completes the table, and we get I think 4 marks for completion of this table. Okay, I hope you understood. Now the B part is complete a suitable scale on the y-axis and plot your results of experiment 1 and 2. The point 0, 0 has been plotted for you. Draw two curves of best fit. Okay, we have to draw best fit. Both curves must start at 0. It already given. Both curves must start at 0. We have to start from 0. First we have to take this axis. Okay, since the highest temperature rise is around 20, so I can take this as 5, 10, 15, 20 and 25. This is the temperature rise: 5, 10 degrees Celsius, 5 degrees Celsius, 5.0 or 5 degrees Celsius I can say, 10.0 and 15.0 or 15. I can also write 15.0, and it is in degrees Celsius. These are my y-axis. This is my y-axis. Temperature in degrees Celsius since time t equal to 0. The first data which we have to plot is at time 0:24 already done. At time 30 seconds, the difference is 9.5. At time 30 seconds, I have to plot 9.5 difference. Now 30 means half of this is 25, and one line is of 5, then so this is my 30. This is 30 point, and temperature at 30 is 9.5. The difference between these two is of 5, and it means one line is of 1 point, two lines of 1 point. I require 9.5. So this is 9 and this is 9.5 at 30. At 30, 9.5 I have to plot. At 30, 9.5. When I plot it, it will come around this point, this point. This is 39.5. Okay, next pointer is 14 at temperature 60, at time 60. Now time 60 is this, and we have to plot 14. 14 means 1 less than this, 60 and 1 less. This will come approximately, it will come here. This will be my pointer. Next temperature is 17.5. Next is 17.5 at time 90 seconds. 90 seconds, 17.5. this is 90 seconds, this point, and we have to point 17.5. 17.5, it is 20, and 2.5, that is 17.5. Half of this. Half of this at this point, I will go up, and then this is half. Around this point will be my 17.5. Okay. Now the next is 19 at time 120 seconds. This is my point 19. 120 120 seconds, it is 19.19. Now at 160 seconds, it's 20. 150, and this is 160. 160 may it is 20. So when I talk about 20, so it will be around this point. This is my graph, pointer 20. Now again it is 19 for 180 seconds. 180 seconds, 175, and then 180. This is my pointer. Okay. Next is again difference is 210, 18. 210 and then 18. This is 210, and we have to plot 18. 20, 17.5 is this, and then 0.5 up, this is 210. If I join them, and this will be my graph for this. And now he's saying this is my graph for the first point. Now next temperature, we have to draw the next temperature from 0 also. The next temperature starts with difference is 2, time 30 seconds. This is 30 seconds, and the temperature difference is 2. This is 2. The first point is for this and this point. Second difference is, if you see the data, the second difference is of 3.5 and then 5. Now at time 30, we have differences 2. At time 60, it is 3.5. At time 60, this is 60, it is 3.5. 3.5, this is 2.5, and then 1, 3.5. This is my at time 60. Now at time 90, it is 5. When the time is 90, it is 5. It will be exactly on this point, and this is my time 95. Difference is 5. Now at time 120, the difference is of 6. Time 120, the difference is of 6. 5 and 1, 6. This is time 120, and the difference of 6. Now at time 160, the difference is 6.5. Time 160, this is 160. 160, the difference is 6.5. At time 160, the difference is 6.5. This is 160. This is 6, and this is 6.5. The second last is at time 180, the difference is 7. Time is 180. This is 180, and the difference is 7. 6.5, and this is 7. And then at time 210, it is again 7. At time 210, it is again 7. This is 210, and this again 7. These are the pointers for this graph. And if I plot a graph from 0, this will be my best fit line. So this is the graph, and this is the first part of question done. Now C part of the question is extra plot the curve for temperature 1 on your graph to deduce the temperature change since time t equals to 0. Experiment 1 after 240 seconds. Now if I want to extra plot this curve at 240 seconds, then I have to go straight down, and I'm extra plotting from this point using another color. This will give an extra plotting of the curve. Okay, this is 240 seconds. I have to extra plot from here, and if I go straight up, a perpendicular is drawn from this. It will touch this point around 14.5 or 15. This will be my pointer. It will be around 14.5 or 15. This should be the answer. If you take from this side also, so it will be around this point. So now extra plotting I'm getting around 14.5 or 15. This is the answer. So this is around 14.5. The answer for this question will be 14.5. Thus we'll write the temperature change is 14.5, and we had done on the graph also 14.5 or around 15. It will be 14.5 around 15. If you draw with a proper pencil on a hard copy, it will be around 14.5 or 15. State which temperature, which experiment 1 or 2 is the most exothermic. Explain your answer. Now if you see this graph, the rise in temperature is more in the experiment number 1. This is experiment 1 and this is experiment 2. Rise in temperature is more on experiment number 1. The change in temperature is more on experiment 1. The answer for this is experiment 1. Explanation is why it is high or more exothermic. Exothermic reactions are those reactions in which heat is given out. So it is more exothermic since more heat is released, and that is visible by the help of higher temperature change. More heat released causing higher temperature change. So we can see in this reaction, experiment 1, the temperature change is higher, therefore we can say it is more exothermic, more heat is released. Next part of the question is predict the temperature of the solution in experiment 1 after 3 hours. Now when the reaction is completed, with this graph we can see the reaction is completed in about 150 or about 200 seconds, and we are talking about 3 hours after the experiment. So whenever a reaction is completed and it is kept at room temperature, after 3 hours the temperature of the solution and the room will become same. So what is the room temperature? We had started with 24.0 degrees Celsius. So it will be 24.0 degrees Celsius. After 3 hours it will again acquire the room temperature, which is 24.3 degrees Celsius. Okay, it will acquire 24.3 degrees Celsius, which is the room temperature. Since we have started from 24, this will be the final temperature of the solution after completion of experiment when it is kept at room temperature. Now next, explain why using a copper container instead of beaker would not be an improvement in this investigation. What is the problem with all exothermic reaction? There are always heat loss. Now when heat loss is taking place, it is taking place through the glass container, and since copper is also a good conductor of heat, heat loss will also be there. So both will cause heat loss. Therefore, it is not an improvement for this investigation. Replacing the copper container with the glass container is not an improvement of this experiment. Reason for this is copper is also a good conductor. Copper is a good conductor of heat. Good conductor of heat. Thus, it will not prevent heat loss. More heat will be lost, or heat loss, that is, more heat will be lost to the surroundings by using this. So there will be heat loss, more heat loss will take place, hence it is not a good improvement. I hope the answer key will have more heat loss to the surrounding will take place, hence it is more heat loss to the surrounding will take place, thus it is not a good improvement. Describe two changes. Now next question is asking describe two changes to the apparatus that will improve the result of this investigation. Each change explain why it improves the result. Now what apparatus we are using here? We are using a measuring cylinder. Measuring cylinder is never a good way of measuring. Instead of measuring cylinder, what I should use? I should use a burette. So the first improvement should be, instead of measuring cylinder, use a burette, which will give more accurate readings. Next, what is taken? He's taking a glass container. Instead of glass container, if I take a styrofoam cup with a lid, what is he taking? He's taking a container, he's taking a beaker. Now instead of beaker, if I take a styrofoam cup prevents, it is an insulating cup, prevents heat loss or causes less heat loss. Therefore, we can replace it with a styrofoam cup. So the 2 pointers which I will write here is, number 1, change number 1 is using a burette. Instead of the measuring cylinder. instead of measuring cylinder. Okay, what it will result? It will result in more accurate volume, more accurate volume measurements. There will be more accurate volume measurements. Number two, because burette gives more accurate readings as compared to a measuring cylinder. And the answer number change number two is use a polystyrene cup. Use a polystyrene cup with a lid, with lid for insulation instead of beaker. Since polystyrene cup is insulating material, polystyrene is polystyrene is polystyrene is an insulating polystyrene is an insulating material, insulator. Thus it prevents, thus it minimizes. Prevent will not directly minimize. It will minimize it minimizes heat loss. It minimizes heat loss to the surrounding. This will be the answer. One more change I can write here is change 3. If you want to write, you can write instead of a thermometer, use a temperature sensor. Use a temperature sensor. And why a temperature sensor? It will give more accurate reading. It results in more accurate temperature change. Okay, so these can be the pointers for this question, the part G of question number 2. Now the question number 3 is a student tests two substances, solution A and solid B. One is a solution, there is a solid. Now test on solution A shows it is already given, it's an aqueous chromium chloride, aqueous chromium 3 chloride, CrCl3 solution. Student divides the solution into 3 approximately equal proportions and completed the expected observations. To the first portion of solution A, the student adds aqueous sodium hydroxide dropwise until it is in excess. Now what we have to see, what will be the result of adding aqueous sodium hydroxide to chromium chloride from the table given below. If we move down to the table at the end, you can see when we are adding aqueous sodium hydroxide, to chromium, a green PPT is produced which is soluble in excess. So when I will move up, what I will write here is observation is a green PPT, green precipitate soluble in excess, forming a green solution, green solution. This will be the answer. Now next is to the second portion of second portion of solution A. The student adds 1 centimeter cube of dilute nitric acid followed by a few drops of aqueous barium nitrate. So we are adding nitric acid and barium nitrate reacts with this. If it will react with chromium chloride, it can form barium chloride, and barium chloride is soluble in water. Therefore, there will be no change in color, no change, or no observation will be there. You will not observe any change. Although a reaction could take place, barium nitrate can form barium chloride, but it is soluble in water. Therefore, there will be no visible change. No change or no visible change. No visible change. Okay, that should be the answer for this. To the third portion of the solution A, the student adds 1 centimeter cube of dilute nitric acid followed by few drops of silver nitrate. Now I am adding silver nitrate to this solution, and when I add silver nitrate to a chloride containing solution, Cl minus are present. These Cl minus will react with Ag and they will convert into AgCl. What will be my observation? A white PPT of silver chloride is produced. White precipitate of AgCl, white PPT or precipitate of AgCl is formed. AgCl is produced. Okay, that should be the answer for this question. white precipitate of AgCl is produced. Now the next table, which is test on solid B, shows if I carry out a flame test on solid B, a red color flame is produced. Now when a red color flame is produced, we'll go back to the table and see. If I see the flame test on metal ions, a red color is produced when it is lithium. Only when it is red is pure when it is lithium. Therefore, my answer for that should be, my identification should be lithium. So from this, I identified it is lithium, Li. Now dissolve the remaining solid B in distilled water to form solution B. Divide into 3 portions. To the first portion, add few drops of acidified aqueous potassium nitrate. Purple color. Potassium nitrate itself is purple color and remains purple color. That means there is no reaction, no change or no reaction. By this we can observe there is no change or no reaction. Now to the second portion of solution B, add about 1 centimeter cube of aqueous sodium hydroxide. Aqueous sodium hydroxide we are adding to the second portion. Then also remains colorless. It means no change again. No change again. Warm the products of test 3 and test any gas given off with a damp red litmus paper. Now what I am doing is, test 3 we had added sodium hydroxide and now we are warming. Sodium hydroxide, no change, solution remain colorless, but when we are heating it, test 3, if I am reacting or I am heating this solution of the test 3, a gas, if it is given out, and it is given out, what is doing it? It is not changing. If it is given out, it should do any change, but there is no change on the red litmus. It remains red. There is again no change in the litmus paper. Now the next test is to the third portion of solution B, add about 1 centimeter cube of dilute nitric acid followed by a few drops of barium nitrate, a white PPT. So whenever you are adding this barium nitrate to a solution, a white precipitate is formed, and this white precipitate could be of barium sulfate only, BaSO4. Barium sulfate is white PPT. If you see the table, we can identify what it is. It is barium sulfate. We go back to the table and we'll see. And we'll talk about this test 3 and test 4, because the question is identify the ion that is tested for test 4. So which ion is tested? We'll go back to the table and we'll see what this test 3, test 4 and test 5 telling us. Now what we are doing in test 3, we are adding aqueous sodium hydroxide and the solution remains colorless, and then we will heat that products and pass the gas, if any, over damp litmus paper. A damp litmus paper test is basically done for, damp red litmus paper test is done for ammonia or ammonium ions. If the solid is ammonium ions, then it would have given ammonia, and that should turn red litmus into blue, which is not so. It means the solution is not containing any ammonium ions. Whereas when we are talking about a white PPT formed when we are adding a small amount of nitric acid with aqueous barium nitrate, a white PPT is produced, which is the BaSO4. So this explains my test number 3, test 4 and test 5. Test 5 is forming barium sulfate, and test 3 is telling solution remain colorless. There is no gas produced. If we are heating it, then also there is no change, and the gas is not turning this damp litmus blue. It remains red. It means ammonium ions are absent. We'll go back to the question. Now what the question is saying, describe how to carry out the flame test used in test 1. For a flame test, what you can take a clean platinum wire loop. Take a clean platinum wire loop, and what then you do? Dip it in concentrated HCl so as to clean it further, remove any impurities or anything, any salt attached to it, and then dry. Then dry or then burn it. You heat it. Burn or heat in a flame. Better is you heat in the flame so that any other salt attached to this, stick to this platinum wire, is removed. Burn in flame. After doing it, now dip the wire, the loop, in paste of solid B. Heat in flame again. Heat in flame. Observe the color. And the color what we are observing is a red. And this red color, what it gives? It is lithium. Okay. Next is identify the ion tested in test 4, as I explained you. In test 4, we are testing for red litmus test, which is for ammonia. So we are doing it for ammonium ion. NH4 plus should be the answer for this. Identify the two ions which are in solid B. We had identified here, it is giving a white PPT of barium sulfate. It means it should contain a sulfate ions. Barium is coming from barium nitrate, and sulfate it should present in the salt B. And what is the second ion? Second ion is lithium, because giving a red color. It will be lithium because of the red color we observed in the flame, a red color flame. And it is sulfate ions, SO4 minus, because it is giving white PPT with barium nitrate. White PPT of barium sulfate with barium nitrate when added. Okay, so these are the two ions which should be present in solid B. Ions means lithium plus, Li plus. So since asking about ions, we will write Li plus ion and SO4 minus ion. Now question 4 says, metal spoons can be electroplated with silver. Describe how a metal spoon can be electroplated with silver. Include your answer. How could you determine the mass of the silver electroplated into the metal spoon? You are provided with solid silver nitrate, a metal spoon, and a piece of solid silver, distilled water, and common laboratory apparatus. Your answer must include diagram. First, we'll make a diagram for this. For electroplating, we know whenever you want to electroplate, the object to be electroplated should be my cathode. It should be always made a cathode or the negative electrode, because it is electrolysis, or its principle, the electroplating principle is electrolysis. And for electrolysis, we use LOAP, left anode, left oxidation, anode positive. Anode in this case will be positive, and this is anode, and oxidation will take place always on anode, and generally it is on the left side of your electrolytic cells, or electroplating also you will put on the left side generally. Important thing is oxidation anode positive, left and right are not important. I will make a diagram for this. As you can see, first thing is we'll take a beaker and we'll attach two electrodes, that is the two objects. One will be the object which will act as an electrode, that is your spoon, which acts as cathode, and the second will be the silver rod which will act as anode. This is my spoon, object to be electroplated, spoon, and this is your silver rod. Fill it with aqueous silver nitrate solution. Fill this beaker with aqueous silver nitrate solution till it will dip the complete spoon. The spoon end should be dipped. The spoon should be completely dipped in this. We'll fill this till the end. Okay. Now connect these two electrodes to the terminals of the battery, and I'm taking it as a positive and negative terminal. This is my anode connected to the positive terminal of battery, and this will act as a cathode connected to the negative terminal. So this is positive and this is negative. Silver spoon will act as anode. This silver rod will act as anode, and the spoon to be electroplated will act as cathode. And this is my electrolyte, which is aqueous silver nitrate solution, aqueous AgNO3 solution. This will be your diagram for this first part of the question. Okay, now we had all marked. One thing more I want to mark is the beaker. This is my beaker, this is beaker or container, and this is my battery. A battery is also there. So this is your complete diagram. Now what the process? You can write this process in pointers. The first pointer is take a weighed, you will weigh a metal spoon, clean it, clean and connect it to clean. How will you clean it? Clean it by the help of a sandpaper. Clean it and suspend in the beaker. Connect it to the negative terminal of the battery, to the negative terminal, which is my of battery. Thus it will act as cathode. This is the first pointer which we should write. Next pointer is, now you will take a silver rod. Take a silver rod or electrode. Connect it to the positive terminal of battery, it will act as it will it will act as it will act as anode. Okay. Oh shit. Now next is place the electrodes in the beaker and start the place the electrodes as in the beaker place the electrodes in beaker and fill the beaker with aqueous silver nitrate solution till the spoon completely dips in the solution. We'll fill till this. Next is connect and start the circuit. Connect the circuit and start. Connect the circuit and start the process. Complete and connect the circuit and start the process. Start the process for we'll start the process for a specific time. Suppose it could be 15 minutes, half an hour. We'll keep the time constant of X. Specific time. After that, switch off the circuit, take out the spoon and dry it with a you can take a paper, that is with a filter paper, by gently pressing it. Now reweigh the dried spoon to find the mass of silver deposited. The difference in mass, in initial and final mass of spoon will give the mass of silver deposited. Therefore, the formula is the mass of silver deposited will be equal to the final mass, because the final will be more, final mass of a spoon after electroplating, spoon minus the initial mass, and that will give you the mass of silver deposited in grams. Okay.